Hi everyone, today we're going to look at the relationship between fuel flow and exhaust gas temperature as it relates to leaning the mixture in an airplane. We've got a fairly simple graph here. Up the vertical axis we have exhaust gas temperature, which is essentially how intense the fire is inside the combustion chamber. And across the bottom we've got fuel flow, or how much gas is actually getting into the combustion chamber. When you adjust your mixture control in the cockpit, it's going to restrict the fuel flow and lean the mixture. Now, starting at the far right of the graph, we have a very rich fuel-air ratio, so lots of fuel for the amount of air that we have. And as we lean the mixture, reducing the fuel flow, we can see our exhaust gas temperature increases to a point and then starts to decrease. Now, I've done a little demonstration with some paper balls that should help illustrate what's actually happening inside the combustion chamber.
See here from the start, we have a fairly tightly packed ball of fuel. Lots of fuel, very little air. This one's fluffed up a little bit more, giving us more air for the same amount of fuel. This one's fluffed up even more. Even more. This one's really spread apart. There's a lot of air for the same amount of fuel. And our last one, we've got lots of air for the same amount of fuel. So what we're going to do now is we're going to ignite each of our balls of paper and see which one burns the fastest. So first, our very rich mixture, lots of fuel for very little air. You can see it's burning very slowly. Next we have our slightly leaner fuel-air ratio. There's more air for the same amount of fuel. See, it's still not burning terribly fast, but it is burning a good deal more quickly than the first one did. Bundle number 3, you can see we fluffed up even more. So there's more air for the same amount of fuel. This is a leaner mixture still. See, immediately the flame is much more intense. All right, on to the next one. You can see this is fluffed up even more. So this is a leaner still mixture. So lots of air for the same amount of fuel. Immediately much faster flame progression. Now this one, our fuel-air ratio is very lean. The fuel is very spread out. There's a lot of air for the same amount of fuel. You can see the flame is having to snake its way down through each of the pieces of paper. It's taking its time. And our last sample, which is very lean. There is a great deal of air for a fixed amount of fuel. Let's see how it does. See, it's so lean that just by putting the ignition source in the middle, nothing happens. If I were to light off a section of it by moving it along a little,
So now we're going to look at how what we just saw in the Great Balls of Fire demonstration applies to the actual airplane. Up across the top of the screen where it's labeled fuel flow in gallons per hour, you can see that as we're leaning the mixture, in the off screen I'm pulling the mixture control towards the idle cutoff position slowly. You can see the fuel flow is decreasing. And then the next set of graphs down is for exhaust gas temperature. You'll see those numbers increasing. This is as we're going from the tightly packed ball of paper into more and more fluffy and loose bird's nest type balls of paper. And then I've sped this video up considerably for time, but you'll see as I continue to lean the mixture, the exhaust gas temperature will begin to decrease. That's where the balls are becoming too loose. It's too lean of a fuel-air ratio to burn quickly. And eventually I'll lean it enough that the engine pretty well stops, which is what we saw in the last ball of paper.